So let us talk about molecular mass of polymers. Now you have to know that in any polymer, the polymeric chains do not have the same length. Now each polymeric chain ideally can be called a molecule. So basically in any polymer, these different polymeric chains are considered to be different molecules of any polymer. And you know that the chain length will not be same for all the chains of any polymer. There might be small differences in the chain lengths, and therefore we cannot have a fixed molecular mass given like the conventional molecular mass that we give for different compounds. So here we will have to consider the average molecular mass or average molar mass. So first of all, for polymers, we consider average molecular mass as different polymeric chains have different chain lengths. All right. So that is one thing. Now, how many different types of average molecular masses can we have? So here we have two categories. So we have one which is called the number average. Molecular mass, which is also shown as Mn, and we can have weight average molecular mass, which is like Mw average. So these are the two important types of molecular masses that we have to understand. Let us start with the first one. Number average molecular mass, Mn average. And yeah, so let us understand this properly. Here we have to know that if N1, N2, N3, etc. are the number of molecules having molecular masses M1, M2, M3 respectively, then number average will be given as N1 into M1 plus N2 into M2 plus N3 into M3 plus and so on, and this should be divided by total number of molecules, that is N1 plus N2 plus N3 and so on. Therefore we can write number average should be equal to sigma summing up I is equal to 1 to I is equal to infinite, and we can put it like this: Ni Mi upon Ni. So ideally this is your number average molecular mass. They may even ask you to calculate number average. Many a times they do this, so you have to exactly know how to calculate things, right? Okay, now we take up the next one, that's the weight average. Let us talk about the weight average molecular mass. So suppose we have our polymer, a sample of our polymer, and if m1, small m1, small m2, small m3, etc., the masses of molecules having molar masses m1, m2, m3, etc., then the weight average can be given like this. Weight average is equal to m1 into m1, that's small m1 into capital M1, small m2 into capital M2, small m3 into capital M3, and so on, divided by m1 plus m2 plus m3 plus, and so on. This is also given as sigma I is equal to 1 to I is equal to infinite, and then we have mi, small mi into capital Mi upon small mi, right? So this is the first part that we have, but you know that small mi, that's the small mi is nothing but number of such molecules in I into molar mass or molecular mass, right? So you have to know that mi, small mi can be given as capital Ni, so that's like the number of such molecules and then their respective masses. So we can put up this as I is equal to 1 to I is equal to infinite. Instead of Ni, we can write, instead of small mi, we can write Ni mi multiplied by mi once again upon Ni into mi. Now this would give us, summing up I is equal to 1 to I is equal to infinite, Ni mi squared upon Ni into mi. So this is the final equation which allows you to calculate the weight average molar mass or molecular mass. Let me put up all this together and you will get this properly done. So we have it here. That's the weight average, right? So you need to remember weight average and the number average, right? These are the two. Now there's also something which you have to know here furthermore, which tells you that if you take the average of, or if you take the ratio of weight average molecular mass and number average molecular mass, you get something called, let me put it properly, this is called PDI. PDI is nothing but Polydispersity Index. Remember, Polydispersity Index for natural polymers PDI is approximately equal to 1, and for synthetic polymers PDI is greater than 1. Any polymer which has PDI close to 1, we call this as more homogeneous this is more homogeneous. Okay, so that is how it goes. As we go close to 1, the polymer becomes more homogeneous, right? So homogeneity is more. That is what we say, right? So this is all about your next part. We've done this here. Just so this is the end of the molar masses or molecular masses of polymers, right? Nothing more to be done here.